that is 8.6. Okay, 8.6. So here, in order to find the point of intersection of the Nyquist plot on the real axis, so how we find there is a point of intersections? So that I will explain now first, then after that we will do the remaining procedure. So here minute. Yes. So from the expressions we got that. From expression we got that for omega is equal to minus infinity, we got 0 plus 0. So when you are drawing that, for example, so this is u plus jv. So here for Nyquist contour, omega is equal to minus infinity, Nyquist plot, you are getting minus 0, no, plus 0 plus j0. Plus 0 plus j0 means plus 0 means right hand side plus 0. Real term is plus 0. So it will be on the right hand side, okay, here, and plus j0 just above. So I can put a point like this. Okay, I can put a point like this. Next, for omega is equal to minus 0. From minus infinity, you should draw it to minus 0. So here you can see that when minus infinity to go to minus 0. So here for a minus, you can see that for minus 0, it is minus 4k minus j0 minus 4k. So suppose this is minus 4k. j0 minus j0 means it will come, point will come here. So I put this as 1, this as 2. From 1 to 2 you should go. Then plus 0 you are getting it as minus 4k plus 0 minus 4k plus 0, that is minus 4k is here only. This is a point 2. This is minus 4k plus 0 means plus j0 means just above this. So you are getting this is point 3. Then when it is omega is equal to minus infinity, you are getting it as 0 plus 0 minus j0 plus 0 minus j0. So you are getting a point just below this. All 0, this is all come together at this position only, but in order to, this is 4. Okay, now the graph should go from here this way, and it should touch like this, and it should come this way, and from here it should start and come here, and it should go like this, depending upon the intersections. So we'll see the intersection here. There certainly there is an intersection. So when you are starting from 1 to 2, the arrow is like this, and here also arrow is like this. When 3, arrow should go to 4, so it is like this. So you know that if minus 1 comma 0 point encircled by this, then you can see there is a counterclockwise rotations. But in order to find that there certainly there is an intersection. That intersection point we need to find. So but what you need to do first, in order to find the intersection point, first imaginary term of your expressions you should equate to 0. That is a common procedure. When you are equating imaginary term to 0, you are getting k omega into 9 minus omega square is equal to 0. 9 minus omega square is equal to 0, you will get it. Then omega square is equal to 9, so omega is equal to plus or minus 3 radians per second. So in order to find exact value, this omega you should substitute in your real part. The value point is obtained by substituting the value of omega in the real part of gj omega, hj omega. So when you are substituting, the real part is, as you can see that it is real part is nothing but k into 6 omega square minus 4 divided by 1 plus omega square all raised to square. So when you are substituting it, omega is equal to 3 or plus or 3. So here omega square, only omega square, so it become minus 3 or plus 3, it will become 9 only. So here also, so when you are calculating it, 1 plus 9, 10 square 100, here 6 into 9, yes, you can see that it is 6 into 9 minus 4. So 6 into 9, 54 minus 4. Yeah, 6 into 9 means 54 minus 4, 50 divided by 100. So you are getting k by 2. So you are getting k by 2. So when you are doing like that, this point, when you are doing like that, again I am drawing that, it's a positive value. So you are having a point 1 here, 2 means very close to this, okay. 1, here it is, 2, here it is, 3, here it is, 4. And the intersection, you are getting a positive value, k by 2. So from 1, it should start, okay. And then it should come to 2, okay. From 3, yeah, from 3, we'll go to the intersections, then from 3 to 4. So the arrow is like this. When it is, no, this is like this. Arrow is like this. Here it is like this. And here, yeah. So here, this way, if k by 2 is a positive value, when omega is k by 3, you are getting a k by 2 is a positive value. It looks like intersection is this side. So it starts from the first point, it will go to the intersection, then it will go to the second point. From third point, should come to the intersection first, then to the fourth point. So you are getting like this. So here, as you can see that this is omega is equal to minus infinity, this is omega is equal to 0. So first from minus infinity to minus 0, then plus 0 to plus infinity. So when you are doing like that, you will get like that. Now, so here we should see that the stability, for stability. So in the stability, examination of this plot reveals that for k by 2 less than minus 1, magnitude of k by 2. So suppose if k by 2 is a negative term, okay, so intersection is coming here, and here you are having that point minus 1, 0. Now if k by 2 is less than, so intersection is less than minus 1, That means if it is before this, then there won't be any such type of encirclement. Means you are having only, yes, if you are drawing in another way, so here it starts like this, or is like this. Another is from here to the intersections like this, like this, like this. So here if it is -1, 0 point, then you can see that -1, 0 point. So you can see that for -1 point, 0 point, there is a clockwise rotations. That means k by 2 is, this is k by 2. K by 2 is less than -1. K by 2 is less than -1. That is one term. And when you are observing here it is minus 4k plus j0, and here minus 4k minus j0. So here k value, this end should be beyond this only. It should not come to this side. So here, when k is greater than 1 by 4, when k is greater than 1 by 4, k is greater than 1 by 4 means, suppose k is equal to 1 by 2. K is greater than 1 by 4. So if it is k is 1 by 2, k is greater than 1 by 4. So k is greater than 1 by 2. So 4 into 4k means minus 4k means minus 4 into k, 1 by 2. Yes. K greater than, k greater than 1 by 4 is, they are telling it, k greater than 1 by 4. If k is equal to 1 by 4, what happened? When you are substituting 1 by 4, when substituting 1 by 4 here, this is minus 4 into 1 by 4, it become minus 4 and 4 will be cancelled. So you are getting minus 1. So exactly at this point, the ending point is you are getting here. That is not possible. So k should be greater than 1 by 4. And k by 2 should be less than 1 by 1. So if I am drawing like that in the diagram, just wait and see. So here U, V, JV. Now this is point 1. This is point 4. Here you are getting 3, 2. So here our condition is k by 2 is less than 1. K by 2 is, so suppose this is our important point, minus 1, 0. K by 2 is less than 1. Suppose, k by 2 is less than 1. Then you know that this will start from here and it will come here and it will go like this. and it will from 3 it will come like this, like this. So angle is like this, okay, and here it is like this, like this. So you can see that it's a clockwise rotation about -1 by g. So that is representation of instability. If in this case k is greater than 1 by 4, k should be greater than 1 by 4. When k should be greater than 1 by 4, if k is 1 by 4, then this point will become here, this point. So it should be greater than, then only you can say that it is instability. So you can see that here it is 4k. K should be greater than 1 by 4, then only k should be greater than 1 by 4. Yeah, k should be greater than 1 by 4, then only this is greater than -1. So this point is this side. So you can see that, then you can see that there is a stability. Now that is one point. The system is therefore, then you can see there is a circle like this. So n is counterclockwise direction, n is -1, p is 0. So n is equal to p minus z. So your -1 is equal to 0 minus z. So z is equal to 1. So you can see that it is unstable. Now in order it should be stable, for which value it should be stable? K should be greater than -2, so that k by 2 is greater than, k should be greater than -2, so k by 2 should be greater than -1. So this point should be, intersection is, that is 1. So that this will be like this, and from here like this, so that it will be including this -1 0 and the counterclockwise rotations. Yes, counterclockwise direction. So 1 0 is within this. That is one conditions, and k should be this k should be and k should be less than 1 by 4. K should be less than 1 by 4. K should be less than 1 by 4. In that case, k should be less than 1 by 4. K should be less than 1 by 4. So you are getting 1 by 8, 4 into 1 by 8. So you can see that so this entire term, this will come beyond this. This point will come, the end point will come beyond this side it will come. If k is less than 1 by 4, this point become beyond this. So there won't be any encirclement. That time also it is stable. Okay. So try to understand this and analyze it 1 or 2 to 3 times. You will get the correct idea.